All right, this is an explanation for problem number 58 in chapter 11. So this problem asks, it states, a championship swimmer takes about 22 seconds and about 30 arm strokes to move through the water in a 50-meter freestyle race. It has three parts to the problem. Part A says, from this table, we know that a swimmer's metabolic power is 800 watts. If the efficiency for swimming is 25%, how much energy is expended moving through the water in a 50-meter race? So, we're given our time, 22 seconds, and we're given our power, 800 watts. Now, to solve part A, we're going to use the equation energy equals P times T. So if we plug in our numbers for power and time, 800 watts times 22 seconds equals 17,600 joules. But we only have an efficiency of 25%. So now we need to multiply that by 0.25, and we're going to be left with 4,400 joules. Part B then asks, if half the energy is used in arm motion and half in leg motion, what is the energy expenditure per arm stroke? All right, so this is how much energy we're that we're using total. So if half of that energy is going into the arm, we're going to divide 4,400 by 2 to be left with 2,200 joules. And then in the problem earlier, it told us that there are 30 arm strokes. So now we're going to divide 2,200 joules by 30 arm strokes, and we'll be left with 73.3 joules per arm stroke. Part C then asks, model the swimmer's hand as a paddle. During one arm stroke, the paddle moves halfway around a 90 centimeter radius circle. If all the swimmer's forward propulsion during an arm stroke comes from the hand pushing the water and none from the arm, which is kind of an oversimplification, what's the average force of the hand on the water? Okay. So to solve this, we're going to use the equation force equals work divided by displacement. So to plug in numbers that we've already ascertained here, we'll use 3.4 for pi and 0.9 because we have 90 centimeters, so we divide that by 10, and we'll be left with 2.826. Now, the average force then, because our force per arm stroke is 73.3, now we need to divide this by our 2.286, and we'll be left with 26 newtons for our average force.